everyone, we're going to find the interval of convergence of the power series given here. We're going to use the ratio test and look at the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. We're going to get our limit and we're going to force it to be less than 1. Alright, so let's substitute everything in. We have the limit as n approaches what? Infinity of absolute value, and then everywhere there's an n, put n plus 1. So you're going to get 2x minus 3 to the power of n plus 1 divided by 5 to the power of n plus 1 times the fourth root of n plus 1 cubed. Put this in parentheses. All right. And now we're dividing by a sub n, which is the same as multiplying by the reciprocal. So this is going to be 5 to the power of n times 4, the fourth root of n cubed, divided by 2x minus 3 to the power of n. Absolute value. All right. Now let's group things together so we can simplify this. Let's write this as the limit as n approaches infinity of 2x minus 3 to the power of n times 2x minus 3, and then put him 2x minus 3 to the power of n here. Let's group our 5 n's together. So that's going to be 5 to the power of n divided by 5 to the power of n times 5. And then for our fourth roots, that's going to be fourth root of n cubed divided by fourth root of n plus 1 cubed. And this is absolute value. Now simplifying, let's see, we can cross these out. So we have this over this. Now, you take the limit of this. This is just going to equal 1. Because basically you're going to have the n to the 3/4 as your lead coefficient. And here it's going to be n to the power of 3/4. And that's just going to equal 1. So we finally have the limit as n approaches infinity of 2x minus 3 divided by 5, and this is just going to be times 1. So your answer is just going to be absolute value of this. Now we take our absolute value of 2x minus 3 divided by 5 and force it to be less than 1. Cross multiply, and we're going to have absolute value. Just put this 5 up here. You're going to have absolute value of 2x minus 3 is less than 5. Now by definition, absolute value, you're going to have 2x minus 3 is less than 5 but greater than negative 5. Now you add 3 to everything, you're going to get, I'm going to move this way a little bit, you're going to get negative 2 is less than 2x is less than 8. And then divide everything by 2, and we're going to get negative 1 is less than x is less than 4. So this is our interval so far. We have to test the endpoints to see if they're convergent as well. So let's do that. For our first one, let's test x. So let's write this. We had negative 1 is less than x is less than 4. So basically I'm trying to see which way I'm going to write it. Is it going to be like this? Or is one of them, if negative 1 converges, then it can equal negative 4. If 4 converges, then it can equal that. It would be something like that. So let's test negative 1 first. So at x equals negative 1, you're going to have the sum, just substitute in negative 1. N equals 1 to infinity of negative 5 to the power of n divided by 5 to the power of n times n to the power of 3/4. Now, using the alternating series test, we're going to look at the sum n equals 1 I can write this as negative 1 to the nth times 5 to the nth divided by 5 to the nth. So these would cancel out, and you're going to get negative 1 to the power of n divided by n to the power of 3/4. All right, so we're going to let b sub n equal 1 divided by n to the power of 3/2, because we have this alternating series, plus minus 1. Now, if you have b sub n plus 2 plus 1, that's going to give you 1 divided by n plus 1 to the power of 3/2. That's going to be less than 1 divided by n to the power of 3/2. So it is decreasing. Also, the limit as n approaches infinity of this is going to equal 0. So it satisfies both condition 1 and condition 2, and it is positive. So it is convergent at x equals negative 1. Now we have to test 4. So let's let x equal 4. And this is going to give you the sum from n equals 1 to infinity. And this is going to be 5 to the power of n divided by 5 to the power of n times n to the power of 3/4. Now this one, this simplifies to the sum n equals 1 to infinity of 1 divided by n to the power of 3/4. Now this series is convergent because my p, or is divergent because my p equals 3/4. It's a p series, and it's less than 1. If it's less than 1, it's divergent. So since at negative 1 it was convergent, you write negative 1. And since at 4 it was divergent here, you have open interval for 4. So basically it's like negative 1 is less than or equal to x is less than 4. It's like that. Thank you. Have a nice day. Bye-bye.